Welcome to the tutorial of CoMPAS CIM import. In this tutorial, I'd like to cover what is CIM, what use case do we have in mind. I'd like to show you an example, CGMES CIM EQ profile, how to import, how to align, and the current limitation of the CIM import. What is IC-SIM? IC-SIM stands for Common Information Model. It is basically a model that describes information within the electrical system for exchange purposes. So if you want to connect your system A to system B and it wants to talk about electrical related stuff, it can use the CIM information model as an exchange, basically as a language between the systems. So where's the common information model used? So the common information model, better known as CIM, is used in the market, enterprise, and operation. So for example, if you do grid calculations, you can use the CIM model. If you use grid planning, you can use the CIM model as well. So what do we have in mind for CoMPAS relating to the CIM model? What's the current use case we support? We support conversion between CIM to 6150 for grid planning purposes. So somebody plans a grid in the CIM model and you want to use that to engineer your substation. So you go from the enterprise side to the 6150 side, which is more focused on station, field, and process. So within the CIM model, CIM is a big model and contains many classes. And in this case, we focused on a subset of it, so-called the Common Grid Model Exchange Specification. And this Common Grid Model Exchange Specification was initially made by the NSOE, but it's now also standardized by the ISC. And it's just a subset of CIM in order to exchange information within DSOs, for example. To give you an example, I will open an formerly CGMES example file and I will load it into CIMdraw. And with this example comes also a diagram. So what you can see here is multiple substations, lines, transformers, and so on. And you can browse it. And in this program, CIMdraw also allows you to make modifications. But there are also other software out there that can deliver you a CIM file. So once you have a CIM file, you can load it with CoMPAS. So what you do is click on Project from CIM, and then you load the EQ profile. EQ is basically the connected equipment that we need here. So now it's loading, and what it does in the background, it converts the CIM into 6150 SCL. So as you can see here, here are the substations below each other, and it contains the substation, voltage level, base, and the primary equipment. In order to check if everything went well, you can go to the single line diagram, and software currently does not support single line diagram layout. So therefore, we created an auto alignment option. And here you can select the substation and it will try to guess a way to display it. And by doing so, yeah, you can see the transformer, you can see the bus bars and how everything connected. And with this, you can start this as a base to engineer your substation, add IDs to it, and so on and so on. So in terms of a mapping used for this software, we also rely on an IEC standard mentioned over here. And we also provide some documentation on what's get mapped and how it got mapped. So you can find it in CoMPAS and then the CoMPAS SIM mapping repository and then mapping.md. And this allows you to check if the mapping from SIM to IEC 61850 maps your use case, or if you're happy with the mapping. It's all open source, so if you like to contribute, we welcome you to be on board. So in this tutorial, I gave an overview of what is SIM, the use case we had in mind, an example of a CGMES file, how you can import it into CoMPAS, how to align it, and some of the limitations.